All right, can you guys see my screen? No, I didn't share yet. All right, so to start off, uh, let's just walk through a quick example of uh, just building a Looker project, building a Looker dashboard, and we'll go through these 8 steps. I'll show you how it all works out. Okay, so this was a recent project I did, and Jake's been also working on it in Data Studio, called AI ML pre-sales. A gentleman from sales, reached out to me a couple weeks ago, said, we want to build this dashboard for sales presentations. Um, so it's a pretty easy project. Um, so step one is they gave us some data. This is fake data that Adam from sales built on his own. I'll first show you what the raw data looks like. And I've stressed to you before, and I'll stress it again, how important it is to do the data cleaning in BigQuery, in the database, rather than in the BI tool, such as Looker. So I'll show you the raw data first. So it's important to always expect data to not be clean. Before you get started in Looker, I think it's best practice to really just go into the database and look at the data, try to understand the data, try to see what fields you got, what format each field is in, and think to yourself, okay, what do I need each field to be as in Looker? Um, so yeah, this is a weird table in that it could be used for many different things, and for the first effort, it's used for this sales dashboard. I was given all these a file that showed like how the data needed to be transformed to be the sales table, and this is the SQL that I did to clean the data, to transform it, to really get it to a final state for Looker to ingest. So it's a simple SQL. It's only one select statement. Um, you know, uh, for some of the fields, which were numeric categories, I turned them into descriptive text. So, for instance, this is basically an if-then statement. It's called case when in SQL. When dem1 equals 0, then treat it as first mortgage. When dem1 equals 1, treat it as HELOC. Same thing goes for this denial reason field, which is initially dim2, which comes in as numbers from 0 to 4. We just put in what each number means. For the metrics, we transform them by multiplying them by a factor. So loan amount equals this raw value times 2.5 million. Credit score equals this R skew by times 850. So this is all the transformation that got done in BigQuery, and I'll show you what the final table looks like. There it is. It's pretty clean now. Instead of ID, it says loan ID. This is just a long descriptor. All the dates are in a normal date format. We got the product, which was once just a numeric category field. Same with denial reason. And then we got the metrics over here on the right. Um, so, this data is cleaned, ready for BI ingestion. So moving on to step 2 is creating a connection off of the database. Good news is I created this project in a connection that already exists in Looker. App Integrations Dev is the project where Project Phoenix Dev resides. So I put it in there. So I'm just recycling that same connection that is used for Project Phoenix Dev. I didn't have to create a new connection. I did go ahead and created a new project called AI ML Pre-Sales, and it's connected to the data. And let me just ingest it again to show you what comes out initially. So what I'm doing right now is I'm importing a table from the database into Looker. Let's find it. Reporting dev, app integrations dev. It's under test data. Viz demo lending. So I found the table in the database, and we're going to create a view off of it. Might not have worked simply because the table has already been loaded. Port the raw data just because that hasn't been loaded. So now it loaded successfully. I'm going to delete this as soon as this presentation is over. But just want to show you, Looker does a lot of work for you, LookML wise. It knows what code needs to be written. So this is the raw LookML that comes out after you connect to a table in a database. So it starts off with the SQL table name, and it's got 3 parts to it, and you always want to delete the project part. You just want to keep the data set name and then the table name. And it does come with all these comments. Just I delete them. I don't want your comments. I don't care for comments. I know it's always important to comment out code, but I just feel like comments get in the way. So I'm not a commenter. If you're not a commenter, it's okay. If you are one, that's fine. But especially this, generic comments, they're not necessary. It's almost just wasted space. It figured out what the primary key is, so it labeled it as the primary key. Do remember that every table in Looker needs to have a primary key defined. That's very important. If you don't do that, then metrics will not aggregate correctly. And sometimes, your primary key makes up multiple fields, and it's pretty simple. You just, make a new field called primary key, and then you concatenate all the fields that make up the primary key. You can even hide the field. Um, so it's always important to define the primary key. it figures out what are the dimensions. It actually takes every single field in the table and defines it first as a dimension. And then for measures, so here's a measure it already defined for you. It is built off of a dimension. So just remember that first step in Looker, it creates a dimension off of everything, whether it's a string or a number. It always first creates a dimension off of it. Now for measures, measures are always aggregated. In Power BI, they're known as aggregated measures, and that's a great name for it because a measure is always aggregated. So for this measure, it's of type sum, and then in the SQL statement is a dimension that's already defined. Notice the difference between this SQL statement and this SQL statement. This one connects directly off of a field in the table, so it's got this table parameter in it, whereas this one is mapping to a dimension in Looker. So, you know, two levels. You know, this is more raw. This is connecting directly to a database field, and then this is connecting to a Looker dimension. And this doesn't have that table parameter in it. So yeah, there's the basic LookML. Let me show you what I got going on in you know, the real actual view that I created a couple of weeks ago. You know, this is a dimension group, so this is special for dates. Any date field, Looker will create a dimension group off of it, which allows you to build a hierarchy. You know, every date inherently has a hierarchy to it. You're going to want to see it by week, by month, by quarter, by year, and by date. So there's all sorts of other ways. Add things you can add to the time frame, such as like, you know, month name, month num. There's all sorts of different time frames you can add, but this is a very nice feature of Looker. It generates it for you, and it, you know, date hierarchies are always, you know, value add. I created some new measures too. So for instance, closed loans, this type is count distinct. And then the SQL statement, you notice how it doesn't have a count distinct in the SQL statement because type equals count distinct. It automatically kind of wraps a count distinct function within this statement right here, this SQL statement. Also note that this SQL statement is directly being processed in the database. If I were to show you the code, the underlying code, you will see this exactly in the SQL code. And this is just a basic case when statement. You know, when the closed loan flag equals 1, then do the count distinct on loan ID, else null, and nulls don't get counted in a count distinct. So it's only going to count closed loans. This is another type of measure. So, you know, in this measure, it's of type count distinct. That's the most basic type of measure, you know, one where the type equals sum or average or count distinct. But then there's a second level of measures that are built off of other measures. And that's what this one is right here, closed loans per application. Closed loans is a measure, and so is loans application. They're both measures. So anytime you're doing like a percentage, a percent of total, you know, those are always second level measures where they're built off of other measures. Anytime you do that, it's of type number. And in the SQL statement, you know, put in the calculation that would calculate, for this case, the closed loans per application. It's a number, you know, a small number, and its value format is %1. There's some special things that you can't do when it comes to like second level measures. Like you can't put in filters. Um, it gets complicated if in order to build this correctly, you got to make sure that all its ingredients are built correctly. What else is in here? Yeah, there's nothing too crazy going on here. Just a lot more measures being built. Um, Pretty basic. Let's go off to the explore now of this dash of this. Oh, I didn't show you the model either. The model is going to be pretty simple. So back to this slide deck, connect to database, create project, connect to tables and database with view files. That's what we just were looking at. And then you connect the views files together with explore definitions. This right here is the explore definition. It is the simplest it can ever be because it's only one table. So it's got the explore parameter and then the fact table. And that's all there is with this data model, just one single fact table. So it's the easiest data model you can think of. So let's go to that data model. So now we're in the kitchen of Looker. I call this the kitchen because this is where visualizations get built. This is the explore realm. So really after you're done with the LookML, after you created the view files, after you created the explore definitions, now you got a data model built, and then you can start building visualizations. So this is a very simple explore definition. It's got one single table in it. You see in black are all the dimensions. That's what comes first. And then down below are all the measures in orange. That's all a table is. It's always going to consist of dimensions and of measures. And that's the same across any BI tool. That's just a generic business intelligence rule. A table only consists of fields of dimensions and measures. And working in this is pretty simple. It's point and click. So um, if I want to show closed loans by product, I put in product, I put in closed loans, and it creates a table. You run this table. What it's going to do, it acts like a pivot table. It only, instead of showing every single row in the data, it aggregates the data by the dimension that is selected. So for field of product, there's only two attribute values, first mortgage and HELOC. So you're only going to see two rows in the data, and then the measure gets aggregated by those two attribute values. So we got 84 closed loans for first mortgage and 74 for HELOC. That's a basic table. Um, you can also add filters. Let's just add a quick filter. Um, let's look at people with good credit scores. So this is just the basic filter part. It's just triangle right here. This right here is pivot. If you ever want to pivot on a table, I'll show you that shortly. Looks like that didn't filter anything. That sure did. So looking at really high credit scores, we see a lot less closed loans. So once you got the table built, then you build a visualization. The perfect visualization for this would be a bar chart. Anytime you're showing a metric by a category other than time, your best bet is a bar chart. You don't have to get too more complicated than that. You have options to change the type that you see right here. A table would also work for this. That's what a table looks like. Bar and column are the same thing. It's just the orientation of the bars, whether it's vertical or horizontal. Same exact thing. Scatter plot, certainly not the right pick for this one, but it certainly is a value. It is a valid type of visualization. It certainly brings about the message that first mortgage mode is at 21 and this is at 18 or 19, and it shows it correctly. Line chart, line charts are usually by time. Anytime there's time dimension, you're always going to want to use a line or an area chart. A lot of people don't like pie charts. I'm in a great disagreement of that. There's a lot of BI engineers that say, never is there a reason to use a pie chart. I think that's not a fair thing to say, because pie charts have been around ever since the very beginning. If you look at your phone, I'm sure you got tons of apps with business intelligence in it, such as like, my Apple Watch has activity and the battery life. It's a pie chart. It shows the battery life from 0 to 100%, and I could show you my phone or my watch right now, but my point being, pie charts are very important. Don't listen to people who say pie charts are never valued. They say that because they think that you can't tell percentages very well in a pie chart. I think it's the best way to show a percentage. You see right here, this is about 50-50. HELOC is 47% and this is 52%. It shows that quite well. I mean, you definitely can see in this chart that this is not 50%. If it were 50%, it would be a perfect half circle. Now, they say that the right way to show what a bar chart or what a pie chart can do is a stacked bar chart. Let me try to create that. This is not the right metric to create it, but just imagine that these two bars were stacked on top of each other. That's what they say is what you should do instead of a pie chart. But with this pie chart, you can clearly see that this is a shade over 50% and this is a shade below 50%. That's the greatest message that you can get from this pie chart. If you stack these two bars on top of each other, it would be very hard to tell that they weren't 50-50. It just doesn't do as good a job as displaying proportions. So for those who say that pie charts aren't necessary, that's not true. Pie charts have been around for 50-40 years, ever since BI has existed. There's perfectly valid reasons to show pie charts. It shows percentages quite well, especially like 25%. You can always tell with a right angle that's 25%. I think we all know how to use pie charts very well. I mean, and they certainly have its valid reason. I don't know where it comes from, where people say it isn't value add. I think somebody important must set it, and then just people are echoing it. But it's been around for 40-50 years. It's certainly value add. There's maps. Maps certainly doesn't mean anything for this. You need map type data. You need location. You need zip code. You need some sort of geography data to do a map. KPIs are always value add. Those are usually what you put up top of a dashboard to really just summarize a metric, not by anything. And then you have all sorts of visualizations to pick from. that aren't the basics. Like I love histograms. I come from a stats background, and in statistics, you're always going to look at histograms first to see the distribution of data. It is more of an advanced type of visualization, and it's hard to do, but Looker does do it, and it does it well. So there's tons, and if there's even more here that aren't even listed here, if you go to the marketplace, which is this button right here, you'll see um, you can download even more off the marketplace. So this is the kitchen of Looker. Once you create a visualization that you like, so like for instance this, you click this gear icon and then you save it to an existing dashboard. I'll do that right now. Let me find out where this where did I put that pre-sales dashboard? There it is. So yeah, this is the basic dashboard that I built off of that data that I was given from Adam from sales. Uh, I wasn't given any direction on what to build, but I was taught the basics of dashboard from Charlie Sanders. He really, gives a broad outline of what a dashboard needs to look like. Up top, you usually put KPIs. So up top, we got 8 KPIs, basically 4 KPIs with a derivation of it underneath. That's why I have blue and dark blue, green and dark green, red and dark red. Um, you know, they're um, they're the they're related to each other. This is loan applications, and this is total loan app amount. This is closed loans, and this is total closed loan amount. So this is the count of loans up top, and then this is the dollar amount of such loans. That's why they're related, and that's why I chose to give them colors that are just a darker shade of each other. Um, this is just a simple line chart showing. It's quite busy. It's got 4 metrics in it. One, it also has a forecast in it. That's a pretty cool feature that you can do in Looker. You can forecast in Looker. I can open that up right now and show you. Um, because these metrics are such at different magnitudes. One is dollar amount, which is a very high value. One is a percentage, so a number between 0 and 1, and one is just applications, a number between 0 and 80. It's a pretty cool feature in Looker. These are all working off of different axes. It's like labeled as left 1, left 2, left 3, and if these were all on the same axis, then these would be ridiculously far away from each other. But because they're working off of different axes, they all show up together. If I were to explore this, show you what kind of goes into this. So you see this forecast button right here. That is where this forecast comes in. So if you ever got time series data, you can always forecast it in Looker. Uh, so you see how we got left 1, left 2, and left 3. Those are the 3 axes that you see on the left right here. So if you wanted to put them together, you would just drag and drop them into the same left 1. But when you do that, now you can only see one of them. All the others are underneath here. So that's not right. Not the right thing to do. We'll take it back. Under the series is where you change the colors of your values, and then you can also uh, select a type. Bar and line charts work together quite well. So if you ever want to change something to a column, that works out quite well. That's where you do it. Whether you want things overlay or stacked, that's where that option comes in right here. I use that quite often. I don't memorize any of all these options. There's not many of them. You just kind of got to, if you're searching for something, you just start from here and you go all the way and just try to find it. I don't memorize where everything is, but I'm definitely used to it. Um, there's quite a lot of options that you can do to tweak a plot that you're making. And each one of these visualization types has its own edit panel that is different from each other. So yeah, when it comes to dashboarding, there's a saying that the top left is always what's going to get read first, and then it goes from left to right. So this would be like number 2 area of most used. So it goes from top left to top right, and then it scans down. So if I go to the very bottom, this is going to be the least likely viewed. This is the bottom right. So it goes from top left to bottom right. That's the order of what's important in a visual. So keep that in mind. When it comes to Looker, most dashboards there's a rule that you always want to put something on the same screen without a scroll, and you can very easily do that in Power BI and Looker, or in Power BI and Tableau. But in Looker, since we are working with tiles and it's not pixel perfect, I think you really need to scratch that methodology of always trying to put it on the same screen without a scroll. I think Looker is meant to have a bottom top scroll to it, much like you see here. There is no such thing as a left right scroll in a dashboard in Looker, but you're always going to have a top bottom scroll. So don't worry about putting something on the same screen without a scroll. It's hard to do in Looker. You don't need to do it. It's meant Looker is meant to have a top down scroll. Yeah, these are line or what are they called? Scatter plots in Looker with a size dimension to it too. So this is a great way to show uh, show show something by 3 metrics. I'll show you. Let's explore this. What I mean by 3 metrics, well, just look at the table. You got 1 dimension, which is the loan ID. So we're really looking at the atomic data. This is uh, the loan ID is pretty much what one row in the table means. So we're not aggregating the data down at all. We're showing information by loan ID. And then we got 3 metrics: total loan amount, average credit score, and close probability. And scatter plots do this really well. You're not going to be able to find another plot that could analyze 3 metrics. But with scatter plots, you got an x-axis, you got a y-axis, and then you got size, showing each loan ID by the 3 metrics. Um, so over on the right, when it comes to all loans, credit score is king. When you're ever going to buy a house or buy a car, before you buy that house, before you buy that car, you should work on your credit score. Try to get it up higher, because then you're going to have a better chance of getting a lower rate and being accepted on the loan. So, higher credit scores uh, have a higher probability that, people with a higher credit score have a bigger circle, because that's what the size means, is close probability. So yeah, that's a great way to show a value by three measures. This is rejected applications, a pretty simple chart showing the rejected reason and then the amount of applications that got rejected by that reason. This is just a simple bar chart. No better way to do that than a bar chart. And these are my favorite, histograms. I don't know if you guys seen histograms before, but these are very special, showing the distribution of data. So for instance, this top right one, let's expand it. This is loan amount distribution. So basically what a histogram does is it, just reading this, we see that the average loan amount application is about 500,000. That's where the peak of this graph comes from. When you see histogram, what it is showing is distribution. So from the lowest loan amount of 130,000 to the highest to 1.89 million. These are all this is the range of all loan applications, and then the x-axis are bins. What they are bins. So this bin right here is, you see when I hover over it, it's the bin of 130 to 140, and there's one record in it. If I go to a larger bin, let's go to the largest bin. This is when loan amount is between 560 and 570, and it has 27 records in it. So basically what a histogram does is it takes a metric and it puts it into bins, and then it count distincts the number of rows that fall into that bucket. And as a statistician, there's no more important way to see the data than by its distribution. So building it is not too difficult. You just put in one dimension, the dimension that you want the y-axis to count off of, and then you put the metric, the metric that you want binned to the right, and then select histogram, and you have many different options. There's simple histogram and scatter histogram. I guess that doesn't work. You can determine the bin size right here. I chose 10,000, but if I were to choose like 50,000, now we see a lot less bins. So that's a cool thing to do. Yeah, histograms you're not going to see too often, but it's great that Looker can do it, and they're certainly value add. If you don't come from a stats background, you probably don't know it too well. But if you do come from a stats background, I'm sure you're very familiar with it, because all stats professors love histograms. Here are more histograms just based off credit score. So looking at the distribution of credit score in this data, we see that most people have good credit scores in the 700s, and then there's certainly a lot of people with low credit scores, but not as many as people with good credit scores. And as far as the highest credit score, it's very rare to have a credit score in the 800s, both in this data and in real life. And lastly, our heat maps showing the number of loan applications by state. So we see most are coming from California and Texas, and then Florida. Lo and behold, those are the three of the most populous states, and New York is also there. There's close probability by state, which looks totally different than the loan applications. We see South Dakota, Oregon, Idaho, and Alabama are the ones that are have the highest probability. So yeah, that's a basic Looker chart. Um, you know, Jake's actually building this in Data Studio or Looker Studio just for his own project. But basic outline of what Looker is all about. I do highly recommend you follow these data points, the simple 8 steps of Looker. First step is we did all the data cleaning in BigQuery. We didn't show you connecting to a database, but that was done. Then creating a project off of that data, that was already done. And then figure out all the views that you need in your data and build the LookML around those views. This is by far the hardest and longest part about Looker is formulating the view files. Then you do the explore definition. That's basically connecting the view files together. Then you build out the visualizations in an explore. You combine out the tiles to create a Looker dashboard. And we didn't show you this, but I'll show you this right now. You can share out your dashboards with clients. That's number 4 of the basic steps of a BI tool known as surface data. When I say surface data, that means broaden out the dashboard, show it across the enterprise. Let's show you what you can do. Let's go off edit mode. So if you click these 3 dots, it gives you options to schedule delivery is where you can email dashboards to yourself. So if I want to email this to myself, you have options of like the 2 best ones are PDF and PNG. If you just want to see the data, then CSV is a great option. That will just show the data as a table. But if you want to see the dashboard and its visualizations, PDF or PNG are really great. So let me test an email to myself and I'll show you what it does. Wait for it to come up, but I'll show you some other ones that I have, emailed to myself. I have a Looker folder in my Gmail. So anything that comes from Looker falls into this folder. And I have, tons of emails that get sent to me that show dashboards. This is the output shown as PNG, not PDF. It comes out exactly as it shows on the dashboard. And this is really great because you can share this with anybody. And the output is right there. You don't have to worry about, the other option would be PDF. So here's output that comes out as PDF. You have to download it. It comes out as like a separate file. But the visualization is very nice. This is part of Project Phoenix showing people who haven't submitted their timesheets yet. This week, we have about 15% of people. But this is the output shown as a PDF. So that looks nice. Here it is. It finished being sent to me. The output in a PDF. Let's download it. And the output looks great. It comes out just like as it looked like in the dashboard. So now you can take this PDF and you can share it with anybody outside of anyone. People outside of Looker can see this now. So that's a great feature. Another thing that is great is called alerts. So within any tile, you can see that bell button. We can create an alert off of any tile. So what an alert is says if the magnitude of the value is a certain threshold, then send off an email to warn the person that that threshold has been met. So it starts off with a condition. So let's say where loan amount is greater or equal to 500. And then it says where to send it. Let's send an email to myself. And a very important part is the frequency of when this alert is tested. So right now it's set at daily at 5 o'clock. You can change it to like hourly, every hour between certain hours, like say between business hours. You could even do it by minute, every 15 minutes or every 30 minutes. So, I have some alerts set up on dashboards, related to Phoenix. It's a very cool feature. All BI tools have alerts, but that's the basic of it. Alerts are really good. That's a nice layer of BI. It's called the prescriptive analytics, where the machine tells you when something's wrong. I mean, that's what an alert does, is it tests the threshold of a value, tests it. Most of the time, it's probably not going to reach the threshold, but when it does, it will send you an email. And that's why it's called prescriptive, because it's telling you something's wrong and you didn't have to do anything. You didn't look at it yourself. The machine figured it out for you. So yeah, that's just a basic Looker dashboard. That took most of our time today. When it comes to working in Looker or any BI tool, like right now I'm learning Power BI. I've learned Power BI before, but what I always do is I create my own personal project. I find data off of Kaggle. You can go to Caggle, and there's all sorts of data sets here that you can download and then build visualizations off of. It's always static data, which you're typically not ever going to work with in real life. Usually, you're working with live data that gets updated regularly. You don't have that, which is fine, but there's tons of data that you can download. I like sports, so I would be interested in this NBA one. But find data off Kaggle, download it, and then go through the process in Looker. Glean it in BigQuery, and then bring it into Looker. Create view files off of the tables. Define the dimensions, define the measures, do everything you need to do in LookML. Define the explore definition, and then get on your way to dashboarding and go all the way through the process. When it comes to learning BI tools, there's no better way than to be hands-on. You're not going to learn a BI tool by reading, by watching videos. The best way to learn a BI tool is by actually working the muscle memory and using the tool, and getting a feel for it that way. You'll know when you get it. It finally clicks to you, and it just takes practice. It takes actually working in the tool. Um, you're not going to get it by watching videos or by reading anything. You gotta actually have experience in the tool. So whenever you have to learn a BI tool, I do recommend you do that. You just find some data and just build your own project. You don't have to show it to anybody. It isn't for anybody but yourself. It's for your own self-learning. That's the best way to learn how to use a BI tool. All right. I'm going to stop sharing. Are there any questions?
I had a quick question about the alerts. I wasn't sure if there's a feature on Looker to where
Oh,
if for part
all right.
of
Well, we got 7 minutes. We can close this early. I really appreciate you guys being part of this boot camp. I hope you
Danny,
learned some things, and you're excited to learn Looker. If you guys, are put in a position where you really have to learn Looker, please reach out to me. I can, help uh, pave that path for you to learn Looker. I can set you up with some projects to work on your own. So please take advantage of that. I was one of the first people at Evident to learn Looker, which was 3 years ago, and then I would say today we have about 40 people who know Looker, and a lot of those people are even better at it than me. So um, we've grown quite a lot. Looker is a big deal for us. It's it's the most common BI tool that our company is going to have projects for. simply because it's Google. We're a Google partner, so the GCP and the BigQuery and the Looker, that's our home base. That's what we do most of. Of course, we do Power BI and we do Azure and AWS and QuickSight, but GCP is what we do most of. So learning Looker is really great for our company, and we welcome more and more learners and Looker professionals into our company. So we're excited to have all of you guys, join that team, join the Center of Excellence for Looker, and thank you for attending this meeting. And that will be it for the boot camp. So have a good rest of your day, and please reach out if you have any questions. If you want to, you need a nudge to learn Looker, please come to me. So, thank you. Have
Thank
a
you,
good
Danny.
rest of your day.
Thanks, Danny.
Thank you.